Hey, what's up, guys? Welcome back to the channel. So, for those of you that don't know, I typically run a 991 or a 992 button box on the sim rig. And I've had quite a few requests over the last few months for a tutorial video on how to build them and how to wire them and how to code them and all that. And I needed to take both of them apart today and make some repairs on them. So, since I'm doing that anyways, I thought I'd go ahead and share the wiring process, the coding, basically, kind of show you from scratch how to build the 991 box. I'll also show you a little bit of the 992 wiring just so you guys can be familiar with that as well. So we'll go ahead and jump in on the 991 and then I'll take you guys through the entire process of putting this thing together and making it work as a functional button box. So let's jump into it. All right, guys. So I'm going to go ahead and start with the more complex button box and then I'll move on to the simpler one and explain the wiring on both boxes that I've made. But when we start over here on this box, you're going to notice a lot of rows and columns, and that's basically how you make the matrix. So right here, starting at the top, you can see this green wire that leads through each of the buttons. There's one in this row, one in this row, one in this row. When you get down here, these are the rotary encoders. They're going to have their own rows and columns. So the yellow wire is the row for the rotary encoders. Then down here at the bottom, it'll get a little more complicated. You'll notice there's only 4 buttons total because it narrows. So what I've done is treated this as if these buttons were all in one row. So they're wired together with the green wire, just like the top ones. And then when it comes to columns, obviously columns go down. So the blue wire goes to each of the buttons, jumping over the rotary encoders because they aren't part of the matrix. And each blue wire goes to the corresponding button so that none of the buttons are in the same row and column, and that completes the matrix. At the end of each row or column, down here is the end of the columns. On the left side is the end of the rows. The wire leads off and goes to the Arduino board. For rotary encoders, you have your one row of encoders, and then each one has its own lead to the Arduino board, essentially as if it were a column, except there's only one encoder per column. Now, if we look at the Arduino board, here on the Arduino board, you're going to see on the left side over here, I've got 4 wires in yellow in terminals 2 through 5. These are each of the rows. Right under that in terminal 6 was an additional wire that I ended up not needing and just cut. I haven't fully removed it. Probably not going to. Below that, you'll see the blue wires, 7 through 10, coming over to this bottom right side. So each one of those is a corresponding column. And then over here at A0, you'll see a yellow wire leading in. This is the one rotary encoder row. And then under that in A1 through 3, you have your 3 green wires, which are each of the columns for the rotary encoder. Now, it's important to remember each one of those numbers because when you go to do the coding for the board, you're going to need to know exactly where your rows, columns, and encoders are going. Now, there's also a black and a red wire. All of the LEDs in the button box are wired to one power and one ground. So the VCC goes to all of the LEDs, and then the ground goes to all the LEDs. And that's pretty much the simple version of how to conserve some space on your Arduino board and wire it up with the button matrix. One thing I did fail to mention is these middle buttons here, you'll see a rotary encoder and 2 switches. I ended up deciding not to use those for both wiring and coding purposes, and there's just enough buttons on this button box. It wasn't really necessary. So they're kind of just duds to fill the hole. They look good, but they don't do anything. Now I wanted to give you guys a simpler, less complicated version of this, though it does look a little messier. This is the 992 button box that I built, and you could see on here that there's only 2 blue wires running down, so 2 columns, and then green wires in between each of the 2 buttons to make the rows. And then I have 2 yellow wires coming out from the rotary encoder and 1 ground from the rotary encoder. All of the red wires go to the positive end of the LEDs, and all of the black wires go to the ground wires. Now it's time to connect to the PC and make sure that we can code the Arduino board properly before putting the button box together. Just in case there's any issues, I want to go back and fix them before I've already installed everything. So once you go into the Arduino software, if this is the first time you're using it, you'll go into Board Manager, make sure you select the Arduino Leonard, and then choose the port you're connected to. From there, you can just copy and paste the code that I will share with you guys in the member page. If you wire exactly like I did, this code will work exactly the same way. If you change any pins or anything, you'll have to edit the code. So you'll want to, for the easiest way, just follow the exact same pin numbers that I use and the same wiring diagram. Then you can copy and paste. You'll see that it compiles just fine. And then on this PC, I'm actually having issues with uploading. I had to do it on my laptop, but if I hit the upload button, normally it would upload. For some reason, I don't know why. On here it won't. But the code's already uploaded. I've already tested it and it works. So I will share that code with you guys if you choose you want to use it. There are two other parts to this that you'll want to do first if you are using Arduino for the first time. This is going to make sure it goes smoothly. You're going to need to download the joystick library, and you could do that by searching it on Google. It comes from GitHub. It'll go into your downloads folder or wherever you download to. You go here to this add zip option under sketch and open that folder from here, and it'll upload the library. You're also going to need the keypad library. So if you go into manage libraries and search keypad, it'll give you the option to install that right here. Now everything's ready to be set up, but before I do that, I wanted to explain to you guys how I put together and printed this button box. So the design itself actually came from printables or something like that. I just searched the 991 button box and downloaded the STL files. For the faceplate, I had the option of either using one with an already made layout or creating my own button layout. I chose to create my own button layout. So that part is unique to me, but as far as everything else, this is pretty much the design that was already available. One thing I did change though, you can see here that the top and the bottom, because I had to print it in two pieces, is bolted together. So I added these bolt points so that I would have a strong structure and it would hold together really strong. Outside of that, this is almost exactly how you would print it. So now that I've explained that, we can go ahead and put this thing together. I found that for this particular box, it's easiest to install it on the side, and you can see here I've added some mounting tape onto the Arduino board, and basically that'll give me the ability to access it from the front and back so that I can add the USB cable in and mount the tape. And at some point before I actually install this button box again, I will hot glue the USB cable to the back of it. So we'll go ahead and install this part first. Now the tricky part is always getting the USB cable in before the mounting tape catches. All right, so I got that in, and you'll notice it sticks up quite a bit. That's why I want to make sure I glue it. Now getting it together just takes a little bit of finesse because that Arduino board's going to sit right between the four buttons. I want to make sure not to pull on the wires too much. Once it all sets in though, I can take some screws and start to get it nice and mounted in there. You'll notice the way I split the lid is right in the middle of the bolts because I wanted to make sure that that split was held down on both sides, hoping that it would help just make this a little more structurally sound. In an ideal situation, I would want to glue it, but I haven't had the best luck with some of my solder points in the past, and I would rather be able to take it apart if something goes wrong. So just gonna leave it the way it is for now. I can always put a very strong mounting plate on the back to help keep it more structurally together. Maybe even glue the mounting plate on if need be. All right, now with the exception of the hot glue on the back, that's done. Last thing I want to do before I would install it is just do one more test to make sure all the buttons are still working. And the way that we test it is we go into USB game controllers. You'll see Arduino Leonard, and then click Properties, and that'll bring up the button test screen, and we can hit each button and make sure that we get a corresponding reaction. So I'll start with the control knob so you can see the little cursor on the x-axis moving back and forth. And I want to make sure I get y-axis, so I do have movement on y-axis. And then the z-axis also has movement. Now, with the way I've coded this, I can't use it. I got to make sure I don't accidentally bump one or the other because they're all in a sequence. Technically, I had enough room on the board to where I could have wired them individually and probably should have, but we're kind of past that now. So essentially, I have X, Y, and Z. Now we want to test the switches. So we'll start with the main power switch. We got buttons 16, 15, 18, 17, 12, 11, 14, 13, 8, 7, 10, 9, 22, 21, 20, and 19. Now the other buttons are used for the rotary encoders, so that's why you didn't see those light up. You can flip 16 back off. Everything is working properly. All right, guys. So as I mentioned earlier in the video, the 991 button box was not my design. That's something that I took somebody else's design and I modified it. So it's not a file that I'm going to be sharing on my member page because I won't share anything that I didn't create from scratch. Now, the 992 button box, on the other hand, is my design. It is something that I do share on the member page. So if you guys are interested, you can go sign up for the base membership and have access to all the STL files and codes that I create and be able to make and build the things that I do for yourself. If you guys are interested in signing up for the membership, I'll go ahead and put a link in the description. I'm also going to include an affiliate link for Apex Sim Racing because they can provide different components for DIY builds and things like that. They also have a great selection of hardware if you guys are interested. Now, I want to know in the comments, which button box did you guys think looks better on the rig? Did you like the 991 or the 992? I definitely know which box I like better, but what looks better versus what I like better might be two different things. So I want to hear from you guys. And until next time, make sure you guys hit that subscribe button, ring the bell, and I'll see you out on the track.